Good morning, pre-calculus class today. We'll start with section 10.2, ellipses and hyperbola. So this one is a continuation with the conic sections. Conic section that involve with circles, ellipses, hyperbola. There's another one, it's called parabola, but parabola, we talked about that in one of those chapters before. So that's considered quadratic functions. So we just want to focus on circle, ellipses, and hyperbola for the conic sections. Especially for this section here, it's all about ellipses and hyperbola. So the standard form, the equation of a ellipse, so quite similar to the equation of a circle. But this one we do have the element in the denominator, so which is a squared and b squared. And then h and k, it's always the center. The reason why that's 1, so 1 is it shows the unit. So that's just the identity for the equation of a ellipse. So one thing that you need to notice, so if a squared is greater than b squared, so that means a is called the major axis. So the major axis, so we're talking about the distance from the center to the vertex. So this one would be considered the major axis. Okay, so for this one, if a squared is greater than b squared, so this one would be a. And then for if b squared is greater than a squared, then b is called the major axis. So if that's the case, so that means we do have a vertical ellipse. So for the vertical ellipse, so it looks like this. Okay, let me get a line. Okay, so the x-axis, the vertical axis, the y-axis. So let's say we have a vertical ellipse. So that means the major axis would be right along the y-axis here. So this one, let's say that it's a 0, comma b. This one is 0, comma negative b. And then a would be shorter, so a, comma 0. And then negative a, comma 0. And as you can see that here, so this one, they're both considered symmetrical. So here's the vertical ellipse. Okay, so we can have either the horizontal one or we can have the vertical one. Okay, so now let's take a look at that. Some of the example here. Graph the following equations. So let me set up the coordinate. Okay, if I do have that, the grids, yes, good. Okay, so we need the x-axis and the y-axis once again. So just want to make the template first. So the template for the x-axis, y-axis. Oops. Okay, let's just redo the line here. Then here's another one. So first thing that I want to find out, it's about the all the central values, so the center. So as you can see that the center here, so h and k, if they're not shown, so that means they're always considered 0, 0. So h, comma k for this, so that's 0, 0. And this one here, so we can see that it's a vertical ellipse because that a squared is less than b squared. So a squared is 9, and then b squared here is 16, so that means a. So the minor axis would be 3, and then the major axis, which is 4. So started with the center, so 0, 0, right here in the middle. So along the x-axis, so we do have a minor axis, so it's 3, count it, 3 units to the right from the center, and then the other side right here, 3 units to the left. So we can always label the point here, so 3, comma 0 for this. So this one is negative 3, comma 0. And this one here is 0, 0, obviously. And then the major axis will be right along the y-axis, so count it 4 units to the top. 1, 2, 3, 4. And then down the bottom, 4 units to the bottom. So 1, 2, 3, 4, like that. So we got 0, comma 4. So over here we got 0, comma negative 4. And then for the vertices here, so the point that we identified, so all you need to do is just connect them. Okay, so let me just make it better for that graph right here. Okay, so make sure that's going to be smooth curve all the way through. So this one going to be connected, okay, all the way. And then the other side right here. Yes, it's very difficult to make that with the pen like this. Or another thing I can do, I can use the curve function. Okay, so let's just make it better. Okay, so this one, it's not a line, looks like a line, but it's a curve. So it's 4 unit down to the bottom. So 1, 2, 3, 4, all the way down here. Here you go. And here's another one. So this one, again, identifying the central element, so the center. So we do have h, comma k, so we do have 2, comma 1. And then the value of a, well, a squared first, which is 25. So therefore a is what, 5. And then b squared, so which is 4. So that means b is 2, taking the square root of the number. Okay, so start with the center, so 2, comma 1, so 2, comma 1, right up here. And the major axis, so what we got is 5, right along the horizontal, which is parallel to the horizontal, the x-axis. So it's 5 units to the right, 1, 2, 3, 4, 5, right here. And then the other side, same thing, 5 units from the center. So 1, 2, 3, 4, 5. You can always label the points, identifying what those points are. And then from the center, so 2 units away, so the minor axis, down to the bottom here, minor axis. So all you need to do is just connect those dots. Okay, so kind of like a football shape. This one's got to be a little bit more smooth. Supposed to be more smooth over here. Okay, so as you can see, that one is a vertical ellipse and the other one it's a horizontal ellipse. Okay, so now let's see what else we have for the rest of this. So complete a square for the following equations, just like the previous lecture. So the one that we have for the circle, so we need to group the like terms and then complete the square. And then also identifying the following, the center, the major axis, the minor axis, things like that. Okay, so first thing that you want to do, again, step 1, always group the like terms. So we do have 4x squared. So nothing is along with that x squared, so we just keep it like this. And then the second group, y squared minus 4y. Now what about that negative 12? So for the constant, we just want to isolate the constant. So take 12 to the right hand side, or we can add 12 on both sides. So for that 4x squared, nothing you need to complete the square for, so just leave that. And then for this one, in order to find out the number, so again, it's b over 2 quantity square. So negative 4 over 2 quantity square. So we do have 4. So we add 4 on both sides. So now what we got here is 4x squared plus, try to factor it, so we do have y minus 2 quantity square. So that equals 16. And now for those you might be wondering, how do we get the denominator? So now here's the thing. So whatever the number that you have on the right hand side here, guess what? Divided by that number on both sides. Okay, so divide that number on both sides. So let me just fix this. That looks kind of weird there. So divided by 16, both sides, for each term, all 16. And then reduce. So what we got here is x squared over 4. And then y minus 2 quantity squared over 16. So that equals 1. And that would be the equation of the ellipse. And also the center, you can find this one pretty easily. So center, which is 0, 2. And we do know that's a vertical ellipse. So a squared is 4, b squared is 16. So b squared is greater than a squared. Okay, so now let's try another one. Okay, so this one again, regroup them. So what we got here, so we got x squared plus 4x. And then 9y squared minus 54y. So that equals negative 76. Okay, so regroup them first. Okay, let me just erase this part here, the one that I did earlier. Again, just want to get more space. Okay, so now, how do you deal with the rest of this? So first thing that you want to do before you complete the square, you want to take out the greatest common factor, if you see any greatest common factor. So anything that's such as a constant, like the common coefficient. So this one, there's no greatest common factor, so we just leave it. So x squared plus 4x. But for the second group, for the y group, we can take out 9. So take out 9, we do have y squared minus 6y. And then blank, so that equals negative 76. So complete the square for this. So add 4 here, because that's b over 2 quantity square. So 4 over 2 quantity square. So we got 4, add 4 here. And then over here, so it's b over 2 quantity square. So we do have 9, is negative 6 over 2 quantity square, which is negative 3 quantity square, so that's 9, so we add 9 here. So now, you want to figure out the number to add on the right-hand side, so we got 4 here, so we add 4. And a lot of people making the mistake here, so they thought that they only have to add 9 for the second group. But it's actually 9 times 9, because that 9, it's the part of the greatest common factor. So 9, the product of 9 and 9, which is what? 81. So that's what we want to add. And then rewrite it. So we got x plus 2 quantity square once you factor it. And then the other part right here, so we got 9. And then the quantity of y minus 3 square. So 81 minus 76, then that'll be 5. 5 plus 4, then that'll be 9. And then finally, divided by 9 for each term. So we do have, well, let's just put it right here. So we do have x plus 2 quantity square over 9. Okay, again, I want to divide it by 9 for each term. And then for the y group, we do have y minus 3 quantity square over 1, because 9 over 9, that's 1. And then, so that equals 1. And that's the equation of the ellipse. So the center for this one would be negative 2, 3. A squared is 9, so a is 3, and then b squared is 1, so b is 1. It's a horizontal ellipse. Okay, let's see what else that we have. Okay, so the next part of this, then that'll be the standard equation of a hyperbola. So we do have two different types of hyperbola. One is horizontal, the other one is a vertical. So for the horizontal one, again, h and k, it's always the center. So h, k, it's always the center of the hyperbola. So hyperbola, that consists with two parabola, so they're both considered symmetrical, either with respect to the y-axis or the x-axis. So for the horizontal hyperbola, so one thing that we notice, so this one has the center. So we do have the vertices, not the center. Okay, so we do have h minus a, k, and then the other one, it's h plus a, k. Okay, so for the horizontal. And then for the vertical one, we do have h, k plus b. And then down here, we do have h, k minus b. So how do we find the value of a and b? It's all about the denominators. Okay? Well, this time, it's not the major axis or the minor axis. So we'll take a look at that. So as you can see that a squared is always going along with that x, and then b squared it's always coming along with that y. If x goes first, that means it's a horizontal hyperbola. If y goes first, then that'd be the vertical hyperbola. Okay, so now let's do the following example. Complete a square for the following equation. Okay, so first thing that you want to do, again, you want to group the like term. So this time, let's start with the y group first because that's positive. So we got 9y squared plus 54y. And then for the second group, we do have negative x squared minus 4x. And what about the constant? Again, we want to get rid of the constant, so subtract 68 both sides. Now before you complete the square for this, we need to take out the greatest common factor. So the first group, we want to take out 9. So we got y squared plus 6y plus blank remain. Second group, we want to take out negative 1. So we do have x squared plus 4x plus blank. So that equals negative 68. So complete a square for this. Again, b over 2 quantity squared. So we got 9 times the quantity of y squared plus 6y plus 9. Again, 6 over 2 quantity squared, then that'll be 9. Negative 1, just leave it. X squared plus 4x. So the complete square for this one. So 4 divided by 2, b over 2 quantity squared. So 4 over 2 quantity squared. So we do have 4. Again, negative 68, carry that over. So the number that we're adding on both sides here is actually 9 times 9, which is 81. And also negative 1 times 4, negative 4. That's what we're adding on both sides. And then this one we want to factor it, so 9. So y plus 3 quantity squared minus x plus 2 quantity squared. So that equals negative 68 plus 81. Then that would be considered 13. 13 minus 4, then that would be 9. And then last but not least, divided by 9 for each term. So divided by 9, so what we got y plus 3 quantity squared minus x plus 2 quantity squared over 9. So that equals 1. So this one, obviously, it's a vertical hyperbola because that we started with y first. So for the value b, which is 1, so b squared is 1, so a squared, which is 9, so a would be 3. So it's a vertical hyperbola. Okay, so now let's see what else that we have for the rest of this. Okay, so part B. Okay, so this one just simply complete the square once again. So 4x squared minus 16x. And then plus negative y squared minus 2y. 11, we just want to take that from the left-hand side to the right-hand side. So we got negative 11. So take out the greatest common factor. So we do have 4 times the quantity of x squared minus 4x plus blank plus, well, negative. We want to take out the negative 1 here because the coefficient. So for the y group, we took out the negative 1 here. So we got y squared plus 2y plus blank. So that equals negative 11. So again, b over 2 quantity squared. So negative 4 quantity squared. Well, negative 4 over 2 quantity squared. So we do have 4. This one here, so 2 over 2 quantity squared. So add 1. So the number we're adding here, it's a product of the greatest common factor and the number we just add. So 4 times 4, then that'll be 16. Negative 1 times 1, then that'll be negative 1. So the rest of this, the trinomial, we want to factor, so it's x minus 2 quantity squared. Negative 1, bring it down, so we got y plus 1 quantity squared. So that equals negative 1 plus 16, which is 5 minus 1, then that'll be 4. And then last but not least, divide everything by 4. So we got x minus 2 quantity squared minus y plus 1 quantity squared over 4, and that equals 1. So this one's a horizontal hyperbola. H comma k, so h is 2, k is negative 1, and then a squared, it's 1, and then b squared is 4, so b is 2. Okay, so that's it. And also, you guys want to take a look at that more rigorous problem, the way that I sketched the graph, you can watch another video that I have on the conic sections. Okay, so thank you for watching this one today. So I'll see you guys next time. Take care.